Everyone, I'm Nivedha Jain and this is my topic bucket sort for algorithm design and analysis course presentation. So what is sorting? So basically you are given a input array of numbers and you want to arrange them in ascending or descending or in any sort of ordering, but for now we are considering only ascending ordering. So all sort could be categorized into two broad categories: comparison based sort and non-comparison based sort. So few example of comparison based sort where we are much more focused on comparing numbers, basically getting the right combination through comparisons. So insertion, merge, heap, quick, bubble, etc. Some examples of comparison based and non-comparison based: counting sort, Reddick sort, bucket sort, and there are many more. But here we are focuses bucket sort, which is a non-comparison based sorting algorithm. So what is the basic idea of bucket sort? So you must have seen various in sabji mandis or in places where you need to sort various fruits and vegetables on the basis of their size. So there is something called something roller sort of going on, and things get sorted on the basis of whole size on which they fall. So all vegetables, or say let's consider apple for the this example, all apples having small size would fall in this bucket, medium size will fall in this, and large size will fall in this. So what we are doing here is something very similar. For sorting, we are flowing numbers through a channel and assigning them to a bucket on the basis of their value, and then we are sorting each bucket independently. So this is the basic idea and a physical analogy what we are doing here. So we are taking one important assumption that our input is a random process and distribute uniformly and independently over the interval 0 and 1, 0 to 1. So this is something our input. So if we divide buckets, say equally, so this would something be division, say they're in bucket. So one can clearly look that probability of falling in each bucket would be 1 by n if they are in buckets. Why? Because it's a uniform distribution. So for example, here are certain numbers in the range 0 to 1. So this would be the output, sorted output. So we divide them into n equally size interval called buckets. Some in some places, in some books, it's also written bins. So if you see the one we previous, we are dividing this into n parts. As numbers are uniformly distributed, the probability of getting in each bucket would be 1 by n. And this uniformness will ensure that not many numbers are in one bucket. They are distributed over buckets. So what we do is we first send them in their buckets and then combine them in order. Like if a bucket has a range from 0 to 0.1 and another bucket contains from 0.1 to 0.2, so we just concat them. This is what we are doing. So here is an example. If there are four buckets, so it would be from 0 to 0.25. You can easily see this. So all these numbers less than this are assigned to here. Next would be 0.25 to 0.5. So one can see this only this number, and similarly you can do this and then just combine this here and this part. So this is how our algorithm works, and this is a rough procedure. So this pseudocode is directly taken from Corman, Introduction to Algorithms by Thomas Corman. So in that book, they have assumed that bucket length in this pseudocode, number of bins is equal to the number of elements in there, which is however not necessary, but this makes the pseudocode clear. No, so basically initialize each bin, then assign each number to bin or a bucket and sort each bucket with insertion sort, then concat as we discussed earlier. So correctness, we can easily see that numbers in bucket I would be less than numbers in bucket J if I is less than J. That's very obvious, isn't it? See, say this bucket is containing 0.01 and this is containing 0.02 to 0.03, then for this I is 0 or 1 depending upon how you place, but definitely this I would be less than this I. So we can say this and we sort H. So if we combine them, it will produce automatically sorted one. Why? Because each bucket is already sorted and you are combining greater numbers in that bucket which are also already sorted. So no need of merge operation, just concat. And one can also think on induction based proofs, just similar lines. One can prove also this using induction. So time based, and let's analyze it on the time basis. This is again taken from Thomas Corman, this pseudocode. But what Corman has done is they analyze on this pseudocode only, and you can see that number of buckets here are in and length is also in. So we give a bit more journal while it's considering this to be key. So this line takes complexity of O of k. This O of n. This is a tricky line. This line runs variably. Let's say each I, it runs O of ni times. In this insertion sort, so let's contain each has ni number of elements, so this run O of ni square times. Now we combine, combination can be done at first O of k plus n. So basically if you combine this, your time could easily be written this part. Now you can see that in worst case, it could happen that all elements are in only one. The probability is however 1 upon k to the power k, which would be quite less, but this could happen. So in that case, time complex, worst case time would be this plus O of n square. Usually k is very less than n. So this would be O of n square just. Or you can also prove that this would be bounded by O of n only. So yeah. Now the task we will do is average case. So expected time using just linearity of expression, we can jump to this expression. Now we do a very tricky substitution. Ni is equal to summation of this, where xi is Boolean variable, which is either 0 or 1. So to give you a feeling of this, let's consider a matrix. Each this way represents your one number, and this way represents your bin. So this would be k, This would be n. Now each number has a chance to go to any of this key. So just say 1, go here to bin 2. Anyway, so this summation would give you ni. So this is what we have written here. And when you solve this again using linearity of linearity of expectation, then you get this result again. Now we can clearly see that if each row number can go in any one of this, so obviously probability of getting 1 is 1 by k, hence which leads to expectation of xij square is equals to 1 by k. Now we know that if I is not is equals to j, then these are independent. For independent, expectation would be expectation of xi j into expectation of xik, which would lead to 1 upon k square. So putting these all value into overall of original equation, this will give us average time this. So let's try to put k is equal to some constant times n. So if you put this, then expected time would be some constant time plus n upon c. Now see this would be just O of n. So this is what Goldman has done. They've used that pseudocode to give the time. So here k is equals to n. So they have got the time O of n. So as we said, if you put k in any theta of n, your average time complexity becomes O of n. For space complexity, this k part is as you need to allocate memory for each bin. Either way you use linked list or anything. So you need to allocate some memory for this. Say these are empty bins now, but each bin has some ni neighbors. So you need to store summation ni. What is summation ni? Just n. So this n part from here. So this much space would be required, and generally this would be equal to O of n only, because usually k is less than n. So what we can do ahead is we've tried insertion sort, but we can also try merge sort. We can also compute meta computing heuristic, which tells us when to take merge, when to take insertion. So there would be a certain number for each bin below which taking insertion is good, and above which taking merge would be good. So this should be certain time on the basis of that number, say n. So we can do this, and this will also reduce our worst case complexity to O of n log n. So this for reference of this one, you can see this book, Algorithm and Data Structures, chapter 1, Algorithm Engineering, and these are all our references we have used for this presentation. Thank you.